Hey there, welcome to the Code Hub, Coding at Home Week 3. I'm just going to shut the door here so we got our sound. This week we're going to dive back into some of the work that we've been doing already, with conditionals especially, and we're going to move on to some new material by the middle of the week. And before we start though, we're going to go over some of the homework that we had over the weekend. Hey there, so the homework we had over the weekend was to work on that quiz playground and build a quiz that we would find kind of interesting. We play around with conditions and a few of the other techniques that we learned last week during the coding classes. I have a student with me here. We're all in quarantine together, so that's why we're not 2 meters apart. And what she did was you worked through the Answers playground this week.
Yeah.
And wrote a bit of code. Some of it's kind of advanced. So we'll talk a little bit about how we coded the advanced bits and then figured out how to troubleshoot some of the problems we ran into, right?
Yeah.
All right, so let's take a look. Let's switch over and we'll take a look at her playground here. All right, so it's called Anya's Answers. So let's pull that up, and I'm not even going to read the code first. We're just going to take the quiz. So we'll run the code. What's my name?
Matt.
I think I know that one. I can hit submit. Oh, the Code Hub is the best. Okay, I'm liking this quiz already. Hi, Matt. Did you have a good day? And I can I have a choice here. I can hit submit and say yes. That's awesome. Yesterday I learned how to shapeshift. I can even turn into Terry Pratchett. Oh, all right, interesting. My favorite color is blue. What's yours? I think I'll pick blue as well. Once I ate an avocado that was blue instead of green, and I turned blue a few minutes after eating it. Okay, so this is kind of nice because this is an example of letting your own personality shine through in your applications. I love puppies. What's your favorite animal? I can pick puppies, pandas, cats, horses, or hot dogs. I pick hot dogs. Oh, one time, oh, that's not great. One time she got one of those stuck up her nose. Not brilliant. What's your favorite food? I'm going to have to pick pasta. My best friend once ate so much pasta that she passed away. Okay, this is pretty bad, pretty bad. Yesterday I had a pigeon. Do I like to eat pigeons? I'm going to have to say probably no to that one, I think. Okay. All right, a little disturbing. A little insight into the maniac's head. Great. So now we'll take a look at the code. All right, so over here we have the whole quiz that she worked on. Now this is a lot of code, but let's step through it. So what were you thinking?
Well, at first it was a really bad quiz because it was just like, hi, what is your name? And then you would put in your name and it'd say hi and then your name. And it was just, I did not like it at all. So then I changed it. So it took, like, I had no idea what I was doing at the start because I completely forgotten all the code, like, and how to do it and stuff. And then I kind of asked you for help for the if statement because it never worked. And then you told me that I was adding in spaces, which you're not meant to put in because then it just gets it confused. And I put in spaces everywhere.
Yeah.
And then if I said if Matt equals name, then show the Code Hub is the best. But that didn't work for some reason. And that was because when you type out the code, it starts with uppercase. So we had to search up on Safari the function. Yeah, the function for the...
Yeah,
for
in
that.
fact, yeah, we just went off to Safari. So if we take a look over here in Safari, we just did a quick search because we knew that we needed to get all the letters the same case, right? And lowercase is the easiest. So we took the text that the user types in, so me in this case, and we said, hey, let's make it all lowercase. So I couldn't remember exactly what the syntax was for lowercasing a string. So all we did was we searched in Google lowercase Swift string. The very first result is from the Apple developer documentation, and it says lowercased. So we don't even need to jump to the documentation at this stage. We can, and we can go read up about it, the instance method. And we're going to get into this a little bit this week, actually, what an instance method is. But basically, it's just a function you can call on a string to make the whole thing lowercase. So that was one bit of research that we did to make sure that your thing worked, right? Your condition worked. Now, we're also going to get into this stuff a little bit this week. So this is a fairly complex condition right here. So she's checking here to see if the string that someone typed in for their name was Dylan, and then she executes some code if Dylan is the input that was typed in. Now, if we look over here, we can see that I typed in Matt. So this one didn't get executed, but we dropped down here and it said, oh, yep, that one matches. So that's why it showed the code hub is the best. A little bit of brown nosing there. That's all right. We also have one for mom, for waffles. Oh, God, I don't know what a dog is doing typing on the playground. Really, really great use of conditions here, though, because we were checking on the input that someone else is passing into our playground and reacting to it. It makes our code way more interesting, doesn't it?
Yeah, definitely does.
Yeah, especially because you can handle so many different cases. You've got your brother in there, your mom, myself, the dog. Kind of worrying. Okay, so what else did we do? We also have here, so you can see that you used a bunch of variables all over the place, right? You have let name equals that. Then further down we have another variable like let day equals ask for choice. This is another kind of advanced thing in the Answers Playground, this ask for choice, where we have a list. And again, this is more tricky syntax. We'll get into this a little bit later. But the square brackets there, and you did that on your own. I didn't even...
I figured out how to do it. If you go to the next page, it shows you
yeah. If you look here, if we tap on text, we can see types. And you'll see different ways to ask. So, okay, cool. So you jumped ahead a little bit to figure out...
Yeah, so I could see how to make the quiz even better.
Okay, cool. And the one she's using is actually the Code Hub Answers Playground. So if you grab it from the Code Hub Playground feed... you'll see that we have these two additional pages, quiz and then quiz with conditions, that lets you work on this kind of stuff. So let's see, we have this where we added our name, so we did show name as well. So the name that someone typed in, we have the day, so when we pick our yes or no if we had a good day. We've got a lot of code here. So here we have a kind of a little bit more complex condition too, right? You did if and then you did an else if. That's cool.
Yeah.
Now, how did you get that added? Did you tap on this button there, or
no,
you just typed it all out by hand?
I just typed it all out.
That's pretty cool.
But it comes up in the bar here. It says if you type out else, then immediately comes up with if afterwards.
Nice. Okay.
So then you can just click on that, and it gives you all the...
Okay. All right, cool. So this is a really, really good example of what I'd love to see for the homework. It's so well done. I love all the conditions. I love that it could change as you go through and answer different things. The pigeon question is a little bit disturbing, but I think it's great. There's a little story there. You could even tell stories with this Answers Playground. So I really wanted to highlight this code, and Anya, thanks a million. This is really, really good. This is great stuff.
I'll go downstairs and continue coding.
All right, so she's going to go jump off downstairs to continue coding, and we're going to do the same. So I'm going to have a tweak to this playground, I think, available on my feed a little bit later. We're going to aim to have it ready for you guys for either today or tomorrow, where you can ask for Booleans as well. So maybe if you're starting out and you want to have training wheels on, remember Booleans we talked about last week and the week before. They're just tests. You're testing to see if something is true or false, on or off, open or closed. I think it's really handy because then with our conditionals, our if statements, they're just using that test. And they're saying, hey, if something is true, then I'm going to execute this code. And then if I have an else statement, otherwise I'm going to execute that. So we're going to keep practicing with our conditionals a little bit today. So... let's try it out. Let's jump back into we are going to jump into our playground. So I'm over here I'm in Learn to Code 1. And what we're going to do is we're going to go through that conditionals chapter a little bit more. And we're going to practice our if statements and our else if and our else's. All right, so let's take a look at using else if. So we're here. This is where we toggled and we had two different options when we landed on a particular square. We wanted to test if we were on a closed switch, and if so, we wanted to open it. And then we also wanted to test on that same square. So if we're not on a closed switch, we want to test to see if we collected a gem. So in Anya's really great example, we could test to see if the name that you typed in is Matt. You could also then say, okay, well, if it's not Matt, let's do another test. So else, if name equals Waffles, do a test for that and run some code. You could have as many else if statements as you could possibly imagine, especially when people are typing in text. There's so many different variations of what they could type that you need to be able to handle all these different cases. So that's one way to handle them, is to use an else if statement. So, okay, so we used our if else if statement here. We're just going to run this to make sure that we remember what's going on. So we're going to hit step through my code. And byte is going to move forward. Check to see if we're on a closed switch. Otherwise, check to see if we're on a gem. Collect the gem. Do the same thing. Done. And you see, now this isn't the cleanest. I've got kind of weird spaces and things here. And as you get better and practice more as a programmer, things like this may bother you. The fact that I've got different spacing here and here, that probably would bother me, because I'd like to have things sort of tidy so that when you scan down the code quickly, especially if we remember back to Anya's playground, there was a lot of code there. We want to have that stuff relatively clean so we can identify very quickly where it is we're doing a particular thing. And when we start to indent like this, here we have a little tab between when we're inside this block, we'll be able to identify code that's being run in different scenarios almost by feel. You'll be able to recognize and say, oh, you know what? That's being done inside of a loop, because I caught the for loop and then all this other stuff was indented. So I know that all the indented stuff is being run over and over and over again. Same thing with my if statement or my else if statement. I know that, okay, if this condition has been satisfied, then I know that this is the code that I'm running, and I know that it's a certain shape and certain size, so many lines. So that's the else if. We beat that particular puzzle. So let's go on to the next. So this is where we're looping conditional code. So last week we kind of had to go back and put the training wheels back on, because maybe we jumped a little bit too fast into the real heavy duty use of conditionals. As you can see, over the weekend, Anya practiced a little bit and was doing amazing stuff with conditionals that was even that little bit more advanced. Now, you may have a really good day where you're writing conditions and you're like, I totally get it. Everything is perfectly clear. And then you come back the next day and you go, oh, what is this code I wrote? What am I doing? It happens. And with practice, those what am I doing days hopefully get less and less. So let's reset this page, because we had messed around with this page before. So let's reset this page to try to solve it again. Okay, so the goal here is to use an if statement inside a loop. So far what we've done is, if we were going to solve this puzzle by hand, we would say, okay, well, we're going to move forward, do our two tests, and then move forward again, do our two tests. And we would have to do that over and over again, like we did in the last puzzle. So now what we want to do is try to use our knowledge of loops and the fact that we've looped through things before to run that code and repeat it for us. Right, so what we're going to do is, we've got our move forward, and if we run this now, we need to give it a number because it'll complain. In fact, watch, if we run it now without a number in there, we'll say, oh, you need to fill in this placeholder. So we need to give it a number. Let's give it 12, right? Because we see over here in this puzzle, there are 12 tiles containing a gem, a switch, or a portal. Okay, so if we run my code, we can see Byte just walking through all of our items here. So now, just like in the previous puzzles, we need to add an if statement in here. And it's the same kind of check. We want to check if we're on a closed switch, we're going to toggle it. So let's start that out. So if we're on a closed switch, we want to toggle that switch. And you can listen as you say it out loud. And in fact, this helps a lot when you're programming. Talking out loud with another person helps a ton. So last night when Anya was working through refining her application, her code for the quiz, she was talking through some of the issues, and we got to the point where we said, oh, do you know what? We want to make sure that the text we're checking is all the same case as the variable that she created. So, okay, well, we got to walk through it. What if someone types in, Matt with all capital letters? What if they type it in with the first letter capital and the rest lowercase? What happens if they type in just every other letter capital? We want to make sure that they're the same. So how do we do that? So we kind of talked through the problem, and that's when we went off to the internet and had a search for lowercase string Swift, and we came up with our solution. So, okay, and as you can hear here, I was talking it through and said, well, okay, if I'm on a closed switch, then toggle the switch. And that's not far off the code that we've written, right? So, all right, so we're going to tap on these two dots here, and we're going to add an Elsif statement because we want to now check to see if we're on a gem, if we're not on a closed switch. Okay, so we'll check to see if we're on a gem. And we'll collect the gem. Okay, is there anything else we need to do? Is there any other check that we need to make? The only other Boolean that we have, remember, on or off, true or false, is on open switch. We don't really need to do anything with that though. So all right, let's try running this, and we're going to step through our code to watch it go through our code. Now, because this isn't a function, Swift says right away, so remember when we have a function here and we don't call it, nothing happens. Because Swift says, oh no, look, you just told me to remember that function name. I don't actually have to run it. In this case, a for loop, it starts executing right away. So there's no need to call it specially because it's a for loop. So now we're running through the for loop and we're checking to see if we're on a gem or on a closed switch, and then we're moving forward. We even check when we're on the portal because that counts as having moved forward. Okay, we're going to check this next one. We're going to see if we're on a closed switch. Nope. We're going to check if we're on a gem. Nope. And we're going to go back up to the top and start the next pass of the loop. Same thing here. We're going to check to see if we're on a closed switch or a gem, and we're going to skip through because we're not. All right, this last one, we're going to check to see if we're on a closed switch, then on a gem, and run the code finally to collect the gem. So hopefully that made sense. This is pretty advanced because really, instead of having to write this 12 times, we just wrote a loop and then enclosed all of our code inside that loop. Really, really handy. And now you're starting to take advantage of the power of code. Because without this and having to write everything out, you're not really taking advantage of coding and all that the computer and these languages can bring to you in terms of ease of use. All right, so let's go. So we've solved this puzzle. Let's go on to the next one. So we've got a few here. So we're going to work through all of these today. We're going to work through the rest of these puzzles nice and slow. I would definitely recommend practicing with these because tomorrow we're going to take a huge jump into something new. We're going to go back to Learn to Code 2, that playground that we had downloaded. We're going to move on to the next chapter in Everyone Can Code Puzzles. Right now, if we go back to the book for a second, I'm in conditional code. This is talking about using Elsif. This is talking about, I love this diagram here, right? Because this is where we check. We move forward. We check to see if we're on a gem. If yes, collect the gem. If no, Elsif goes over here, is on close switch. I love this little diagram because it explains to you how it's sort of the flow of the program and the flow of the code. And this is us inside that loop, right? I really like these for explaining conditions and letting you kind of feel what exactly is going to go on when you run your code. So let's try it. So now we're going to get into defining smarter functions. So let's go check it out. Back to the playground. We did looping conditional code. Now we're going to try out our conditional climb. And we're going to reset this one. Okay, so they've already gotten a bit of template code written for us, right? So we have our loop started up already. It's for 1 to 16 times. Cool. So we're going to do this 16 times, and I'm guessing that's how many squares there are. So let's see. We're going to go and check a certain condition. So let's figure out what condition we need to check. So a condition like is on gem is either true or false. It's known as a Boolean value. Great. So in this if statement below, use the Boolean condition is on gem, I'm right here, and add commands to run if the condition is true. All right, so let's do that. Let's tap on condition. So it turns blue. And I'm going to check to see if I'm on a gem. Because there will be no switches in this particular puzzle. So if I'm on a gem, what do I want to do? More often than not, I want to collect the gem, right? So collect the gem. Now, if I have a look at this puzzle, and these aren't going to be regenerated, the position of these gems is not going to change. So what happens if we analyze this puzzle and try to figure out what code we need to write? What do we need to do? We need to do something, right? Well, let's try running our code, stepping through our code to see where we fall down. All right, so we're going to start. Byte's going to head off to the races. Going to move forward. We keep checking to see if we're on a gem. We're not yet, so we're just moving forward. Still not. Okay, now we're on a gem. All right, we've collected the gem. Now, after we collect that gem, we kind of need to turn to go get the next one, don't we? Because now we're just going to walk off the edge. Okay, so let's save Byte from going over the edge. And if we look here, so when we were back on this square, we needed to turn left. So then we would be moving forward because we're not on a gem, moving forward. We'd hit this gem. We kind of need to turn left again. Okay, so we are able to loop this code. So at first, if I looked at this code first, I'd be worried that maybe there was no pattern and that I couldn't loop this code to save myself having to write a whole bunch of lines of code. Let me add in a turn left and see what that does. Let's see if the hint gives us any hints here too either. Okay, so it's telling me try keeping your else block just as it is without changing the move forward command. Instead, modify the commands inside your if block. So that's what we did because our condition where we kind of need to change things. We can't just keep moving forward. We need to turn left and then move forward is when we hit a gem. So that's our major hint. So let's try running this code here. Now we're going to step through it again. Okay, we're moving forward. Now we've hit, now this is where we went wrong before. So we collected a gem, turned left. Excellent. Now we check to see if we're on a gem. We're not on a gem anymore because we collected it. So we move forward. Check to see if we're on a gem. Move forward again. Okay, cool. There we are collecting our gem and turning left. Those two commands seem to work well together. Now, you might find it easier. So we look like we solved it. I think we're nearly there. But you might have looked at this the first time and said, oh man, I'm going to have to write all this code out by hand. And you know what? There's nothing wrong with doing that first pass. If you need to kind of brute force it and just say, look, I'm going to do it the hard way and I'm going to write out every single line, more than 16 lines, because it's going to be all of these lines 16 times. That's fine. Even if you say, you know what, I know if these don't change, then I can just walk through and say, all right, move forward, move forward, move forward, collect gem, turn left. I could write that code and it'll work just fine. And then go back and read over the code and say, oh, how can I fix this? How can I make it better? How can I make it so that I have less lines? This is great when you have this few lines, because the fewer lines of code, the fewer bugs you're going to have. Or the fewer lines to look through for bugs you're going to have anyway. All right, so we solved this particular one. We did, with this little change, just adding a turn left and collect gem, we solved this particular puzzle. So let's move on to the next one. Hit the arrow there. And now we're in define smarter functions. So this one was mentioned in the book. If I jump out to the book really quick, and you don't have to do this, there's even a page for this for you in the student edition. So it'll talk to you about the goal. It'll tell you to experiment, which I love. Learn the syntax. So there's this thing called nesting, right? So that's where, so far, we've only had really kind of one set of braces around the others. And I talked about that indenting. So if we go back to Swift Playgrounds, and we go back to the previous page, this starts to get a little more complicated, right? So there's a tab here, and then I have a new brace, and these are indented that little bit further. And same thing here. That one's indented at the same level as collect gem and turn left. That's what I was talking about when I was mentioning that you can easily scan the file and say, this code is going to get run only in a special case, in a special condition. So that's kind of handy. So when we go off to our defining smarter functions, this is where we're going to see it, again, get indented that little bit more. And most editors, like Xcode, when we get to Xcode, or Swift Playgrounds, will do this indenting for you to help you out a little bit and make it visually very clear what code is being run at what point. So the goal of this playground is to use a function, a loop, and a condition to collect gems or activate switches. Okay, so in this puzzle, every forward movement might lead to a gem, a switch, or nothing at all. So this is where we're going to do our if is on close switch, toggle the switch, else if is on gem, collect a gem type of code, right? So the wireframes will show the locations where the items might appear. We don't see an example of that, but if we hit run my code, nothing's going to happen. But what we'll see is our wireframes will show up and stuff gets randomized. So there's some open switches, there are closed ones, there are gems. Okay, so we're going to solve the puzzle. We could write lots of if statements, but there's a better way. So we could write the whole thing out, like I mentioned with the previous puzzle, and for every tile in that 16 tile puzzle, have it check to see if there's a gem and collect the gem if there's a gem. Or we could use that for loop that we used. So we're going to break this puzzle, like it says here, into its basic patterns. And there are 3 major paths, each with 2 possible gem or switch locations. So we're going to use an if statement. Define the collector toggle function to check the contents of a tile. So this collector toggle, we can now call, well, once we write some code for it, and it'll do 2 things for us. It'll check to see if we're on a closed switch, and it'll check to see if we're on a gem. So let's write that code. So in collector toggle, we're going to use an if statement. So if we're on a closed switch, we are going to toggle the switch. We've written this code a bunch of times, right? We're going to tap here on the 2 buttons. Whoops, not there. We're going to tap on this brace here, And we're going to add an Elsif statement because we want to check a condition. Now, this is an interesting point, actually. If we change this, if we said, do you know what? Let's hit this button to undo that last move. Let's add an else statement. So if we're not on a closed switch, we're going to collect the gem. Okay, so that's collect or toggle. One of the two is always going to happen on this. So because if we're not on a closed switch, we're going to try to collect the gem. And then below my function definition, call collector toggle and other commands to solve the puzzle. So all right, so let's start off. Would we call collector toggle on the first one? Probably not. We want to move forward. So let's move forward. And then move forward again. Because I believe it's only the last 3 tiles that have a puzzle on them to solve there. So let's move forward twice and collect the, actually not just collect the gem, we want to collect your toggle, right? So collect your toggle. And then we want to move forward and then move forward and then collect your toggle again. At this stage we'd be here, so we want to turn left and we'll need to go down 2. So we'll turn left, move forward twice so that we are down here. And then we're going to turn left again to get facing back up this way. So now we're going to move forward twice. And I'm repeating myself a lot, so I have a feeling as I'm writing this code that I could probably either create new functions out of these steps, or I could maybe dump them in a loop. But let's see. We'll take a look at that after. So we've moved forward twice. We're now on that switch. So let's call collector toggle. And then we're going to move forward twice again. So we're on the last tile in this middle row, and we're going to call collect or toggle. Now we're going to turn right. We're going to move forward once. And we got to turn right again, right? Because now we're facing this way. So let's turn right again. Now we're going to move forward once. Twice. We're going to collect our toggle because we're on this switch. We're going to move forward twice. This definitely feels like a pattern. Who's figured out the pattern? And then call collector toggle. So let's try to run my code. See what happens. All right, so it gets randomized. Yep, thankfully the pattern stayed the same. We're on a closed switch, so we toggled it. Nope, we're not on a closed switch, so we just jumped up and collected the gem. Now we call collector toggle. Ooh, we tried to collect a gem, but there wasn't one there. Interesting. So same thing there. That's an open switch. And this is a gem. So we should check to see if we're on a closed switch. Check to see. And then otherwise we just collect the gem. And we tried to collect the gem again. Okay. Interesting. We have a little bug in our code that didn't hurt anything. We solved the puzzle. As you can see here, we got a little congratulations message. Now let's close that though and have a look at this. So we were jumping when we were on this open switch. Because we're checking if we're on a closed switch, toggle it. Otherwise, every other case, so if we're on a closed switch, or if we're on an open switch, if we're on a gem, or if we're on a blank tile, we'll try to collect the gem. So that's not what we want. So this is where we would want to add an if statement here. So if we add else if is on gem, and then we would want to collect gem. And we can delete that because we don't want to collect gem in the other case. Now we could leave that like this and have an empty else case. That doesn't do anything to us. But for cleanliness, I would probably prefer deleting that. Now, if I delete, actually the way I was planning on deleting first. So if I delete and I try running this, I'm going to have a little error. I don't know if you can spot what it is there. So this is really handy. I love this particular feature of both Xcode and Swift Playgrounds. It's telling me here that I have an extra brace, closing brace at the top level. So when Swift takes a look at this file, it looks down here and says, okay, cool, there's a brace, there's a closing one, or there's an opening one. So I have two open ones right now. Oh, there's a closing one, so that one's closed. That last one is closed. Oh, I have another opening one, so I'm waiting to look for another closing one. Found the other closing one. Found another closing one, so that matches that guy. And then I come to this one that's just sort of floating all on its own then. So I've got too many braces and it doesn't know how I meant to group the code. So actually in this case, it makes a good guess and it gives me this fix button. So if I tap the fix button, well, it's trying to delete this one, which is it's not able to do. So what I'll have to do is I'll have to delete one of them myself. All right. So cool. We've just written a collector toggle function that contains a bit of logic inside it. So we can call this function if we think we're on a tile that might have a gem or a switch that we need to toggle or collect. So this is all fine. And if I run this code, everything will look great. Everything will perform well. When I'm on a gem, I'll try to collect a gem. If I'm on an open switch, I won't try to collect a gem. You can see I just ran right by that other one. Collected a gem, collected another gem. I'm on a switch that was closed. I opened it. So this would be fine. This is a lot of code here, and a lot of it that looks repetitive. You can see that I move forward twice, collector toggle, move forward twice, collector toggle, turn left. Let's take a crack at making this a little more sophisticated. So we have these 3 rows. They all have the same number of tiles. Let's write a new function. Because it says at the top, use a function, loop, and condition. So let's create another, because we wrote a function earlier called solve row. So let's do a new one called solve row in our particular case. Okay, so now we have a body that we have to write to this. So how are we going to solve a row? We're going to probably move forward, collector toggle, move forward, collector toggle. Well, maybe not turn left, right? We want to leave that out because further down, if you remember, we turn right. So, okay, that would solve a row. Because then we have, let's see, this turn left, move forward, turn left. That's to get us around the corner. And then we start again, move forward, collector toggle. So far that matches those 3 lines. And then move forward, collector toggle. All right, cool. So we can get rid of this guy. We can delete that, delete the next line down, delete the next line down. Okay, so now we have our function solve row, and let me clean that up a little bit just by deleting some empty lines. So let me start off by calling solve row because I want to solve that first row, right? That's the code that we ran first is move forward, collector toggle. So let's call solve row. And then we do our turn left and move forward. Okay, that's cool. After we've done that, we're going to solve row again. And then we turn right, move forward, turn right to get around the corner. And then we do the same thing again. Move forward, collector toggle. That's exactly what we have in our solve row. So let's select all this stuff and delete it. And we're going to say solve row. Okay, so that's not bad. If we look here, we have a solve row We have our code to turn around the corner, which is different. There's a space there, right? Then we solve the next row, and then we turn right, and we move forward and we turn right again, and then we solve the next row. So that's not bad. This is pretty good down. I like down here. I'm pretty happy with down here. Now, if we look at this function, though, we kind of do the same thing twice, right? We move forward twice, and then we collect or toggle. If we want to try to write this yet a different way, what we could do is move this down, and we'll create a for loop. So I'm going to tap the for loop because I want to repeat something, right? So for 1 to 2 times. Now I'm going to drag this bottom brace around the code that I want to repeat. And then I can delete these 3 lines. Now this is only me just messing around, seeing if maybe this is a decent option for us. You don't necessarily need this loop, especially just doing it twice isn't a huge deal. But let's run this at normal speed and see how this works for us. Okay, cool. So we've called solve row. We're doing our little loop where we move forward twice and then we collect or toggle. We're in here. Now we're solving our next row. We're moving over to the final row and we're solving that row. So we're back up here. So not bad, not bad. That's one way to solve it. And you could solve this a dozen other ways with other combinations of code. In fact, I could have said, actually, instead of looping inside of my solve row, I want to just write this with for loops instead of creating another new function called solve row. I just use this because we've done that in the past. And you'll find that as we go through more playgrounds, you'll recognize patterns and you'll say, oh, do you know what? I've solved this before. I'm going to use that same technique or maybe even that same code and solve that problem the way I did the last time. So let's see. Let's do one last playground before we take off for the day. So defining smarter functions we did. Let's go back. Let's do boxed in because these last two are kind of optional. So this is another example of going and analyzing your code in the puzzle and how you want to organize your code. You can see here that they mentioned factoring your code. You might hear that a lot when you're programming. You know, it's basically just a way you're organizing it and breaking it down into smaller chunks to solve it properly. So how would we solve this particular puzzle? We start in the middle. We step out into that first tile. We're guessing it. So it says here, we're surrounded by a grid of possible gem or switch locations. So how are we going to solve this one? My gut says maybe we just move forward, turn left, and then just keep walking around the grid. Maybe that's the way to do it. So let's write our function to do collect or toggle because we'll need that for each one of these steps. We'll be calling that a lot. So let's say create func. We'll call it collect or toggle. We'll tap down here to write our function body, which will be an if statement. So if is on a close switch. We'll collect the gem, or actually that's not right? That would be a bug. We won't do collect gem, we'll do toggle switch. We'll add an Elsif statement. So if it's on a gem, now we'll collect the gem. Now you notice this other one is blocked variable. So what do you think that's going to do? Well, I'm going to have a wild guess, and I'm going to say that, well, if we hit any of these walls, that means that we're blocked. So let's see. Could we use that somehow? Maybe we'll add an else if statement here and turn, or will we do it down here? Let's do it down here for kicks. So all right, that's our collect and toggle that we want to use. So we're going to start ourselves off by moving forward, and then we're going to collect or toggle. Now we know that we're blocked. So, okay, we're going to turn left at this stage. And we'll try to solve the puzzle by going around like this. Now, you might do it a different way. You might say, you know what? I want to go turn right, or I want to go forward and then backwards and then over. And again, there's so many different ways you can solve this particular puzzle. So let's turn left. We're going to move forward. So, okay, so that's cool. We've now got our move forward command. Now, if I'm thinking about this, and I really like to use that is block command, we're gonna have to think about that a little more and see if there's some way we can write code to use that to our advantage. So we've moved forward. We're gonna call collector toggle again. At this stage, we're here. We'll turn left. Move forward again. Collector toggle. Now we're not blocked. We can just go straight. So we can say, okay, cool. Let's move forward. Collector toggle. Move forward again. Collector toggle, because we're here now, right? Then we'll want to turn left. Because we're kind of blocked here, right? And I don't know, we'd have to test to see if that returns is blocked. So then we'll turn left, we'll move forward again. We'll collector toggle because we're here. Now we can move forward because we're not blocked. Now, if I listen to myself talking through this, I'm actually running a lot of that logic to see if I'm blocked or not. So there's got to be a way that we can offload that to Swift Playgrounds to let it figure out, hey, I'll figure out when I'm blocked and then I'll do the turn left. Because that's the main thing I'm doing. Every time I'm blocked, I turn left. So let's run this and see how far we've gotten anyway. Let's see. Off I go. I'm checking my collector toggle. Cool. Collected my gems. Oh, I've almost gone off the edge. Uh-oh. So I missed a turn left there somewhere. Okay, so I'm at the very end. Now I still need to turn left. Then I need to move forward. Now I also probably want to go back and figure out where I was moving forward without having turned left. But we can come back to that. So move forward. Collector toggle. Now we're here. So we really only have one more square to go to. So we can then just move forward and collector toggle. So let's run our code. Okay, here we go. Nothing to do there, nothing to do there. We've turned. Now, if I really wanted to find out where I'm not turning left and I should have been, I could step through my code and I would see the line where I almost didn't bite off the edge. Okay, ooh. So I completed the puzzle, but I forgot to include a for loop. So I ran 27 lines of code, but with a for loop, I'd only need 12. Well, I like that. Using less lines of code, because that's a lot less lines of code to try to debug if I make a mistake. So let's see. So over and over again, I'm moving forward and collecting or toggling. And then occasionally I turn left. So it looks like I've talked through it. I think I've got it now. So if I run a for loop here, then I do it Is it 12 times? Probably not. It's 9 times. I'm going to write a loop here where I'm going to move forward. I'm going to collect a toggle. And then it's going to go and do it again. But maybe what I need to do is the same check that I was doing before. Every time I collected or toggled, I then checked and I said, hey, if I'm blocked, then turn left. So let's do that. So let's use an if statement. So if is blocked, and we'll see what is blocked does. I'm not entirely sure how it behaves all the time, but we'll see as we run it. If it's blocked, then we'll turn left. And that's it. Turn left. Okay. So all this code down here looks great. Kind of does the job, but I don't need it. So let's drag from this little cursor and delete it. So let's try running this code. There we go. We're checking. Oh, well, we turned left, so we definitely, the is blocked was yes. Same there. Well, let's see if I turn left here at the end. Nope. Yep. And I didn't send him off the edge. Nice. Okay, and we even went one extra step, so maybe we could do this 8 times instead of 9 times. So let's try stepping through that and then we'll call it a day. So we'll step through our code just to see what's getting executed here. I'm moving, collecting or toggling, and then checking to see if I'm going to jam or a close switch, and then jumping back into my loop. And you can see when I hit the is blocked, when it's true, I drop into the turn left function. Oh, cool. We collected the gem. I really, really encourage you to use this step through my code speed, especially early on, because it's so helpful to be able to see what lines of code are getting run at what time. And it goes slow enough that you can watch and see where the little cursor is, and then look over and see where byte is. And now we've written this code today that looks pretty impressive. I mean, this is great. And it's the same thing with Anya's Answers playground from before. It's really impressive code. It's a lot of code. Now, you might come back tomorrow and look at this and go, good Lord, what have I done? I don't know how this works. Step through your code, run it again and see what lines are being run when. And you might get a feel for it and it might come back. And then you do it the next day when you come back and you say, oh, I've forgotten it again. And it starts to catch on. You'll get it quicker and quicker as you go through and say, oh, yeah, that's right. This code gets executed first. I'm checking to see if I'm blocked and then I turn left. And if once I've done that, I move forward and I collect or toggle. And if we had is blocked check after move forward, collect or toggle, we might have seen that, do you know what? We make a couple of steps where we try to move when we're blocked when we shouldn't have. So maybe we have to move that code around. Now this code isn't the end all be all. We could tweak this. You could have done it a bit differently. You could have turned right instead of left. There's lots of different ways to do it. I would love to see some of your work. So definitely feel free to post it somewhere on social media at #everyonecancode. Send it to me in an email, put it on Google Classroom or the discussions board. The links for those are on the website. I'd love to see the work that you're doing. I was so impressed with the amount of effort that Anya put in on her quiz. I think it shows a lot of strength of character to go stick with something that maybe doesn't work right the first couple times you run it, and you go, why did my code not run? It takes a special kind of focus to be able to go and debug something like that, and it'll serve you really well in the long run, not just in programming, but I think in life in general when you stick with stuff. So that's it for us today. The last little treat I'll give you for making it this far in this very long session today is if you haven't discovered it already, if you tap on Byte will actually take off up the screen, and you'll have the choice to pick a different character here, Blue, Byte, or Hopper, to run through your playground. So if I pick Hopper, Hopper will float back into my playground. So you can actually run your code with a different creature if you're a little bit sick of torturing Byte. All right, look, that was a really long, fun session today. I think we've really gotten around conditionals. You guys have done a great job figuring out how to use if and else if statements at this stage, and then what happens when you just use an else statement with an if statement. And tomorrow we're going to be getting into types and initializations, which sounds kind of scary, maybe is a little scary, but we'll work through it. All right, see you tomorrow.